will be years before that project becomes a reality. If it goes as planned, the journey to Proxima B will take about 20.
Quite a few instances over the years, and it doesn't surprise me. I mean, again,
the clearest image of Proxima B ever captured has just been released by the James Webb Space Telescope, stunning astronomers and captivating the global scientific community. Nestled just over 4 light-years away in the Alpha Centauri star system, Proxima B has long intrigued researchers with its tantalizing position within the habitable zone of its red dwarf host, Proxima Centauri. Now, for the first time, humanity has a direct, unprecedentedly detailed look at this exoplanet, a small rocky world that has hovered on the edge of possibility, seen only as a faint signal in the wobble and dimming of distant starlight until now. This image, refined through layers of thermal and infrared imaging, offers not just a glimpse of another world, but a new chapter in exoplanetary exploration. Before we start, hit the like and subscribe buttons for more exclusive news. What makes this image so monumental isn't simply its clarity. It's the culmination of decades of advances in optics, engineering, and interstellar observation. The James Webb Space Telescope, deployed into its orbit beyond the moon's gravitational pull, has finally turned its mirrors and instruments toward Proxima B with an intensity no other telescope could manage. Unlike Hubble, which excelled at visible and ultraviolet light, Webb operates primarily in the infrared spectrum, allowing it to pierce through the interstellar dust and the noisy radiation of a red dwarf star to isolate the thermal signature of the planet itself. The image reveals not just a silhouette or vague sphere, but actual surface gradients, hints of topography, atmospheric composition, and even potential climate patterns. Shadows and illumination play across a terrain that, for all its alien nature, feels hauntingly familiar. Proxima B has long been a planet of curiosity. Discovered in 2016 using radial velocity methods, its mass was estimated to be about 1.2 times that of Earth, putting it squarely in the range of rocky terrestrial worlds. What made it exceptional, however, was its orbit. At just 0.05 astronomical units from its star, only about 1/10 the distance of Mercury from the Sun, it nonetheless sits in the habitable zone thanks to Proxima Centauri's much lower luminosity. Yet because of its proximity to its volatile, flaring parent star, questions loomed about its capacity to support an atmosphere, let alone life. Those questions have now entered a sharper, more informed phase of inquiry thanks to this landmark image. The detail in the image allows scientists to begin inferring atmospheric characteristics that previously could only be speculated upon through spectral analysis. By dissecting the infrared light patterns, researchers are already identifying chemical signatures that could point to a stable, albeit thin, atmosphere. There appear to be regions of thermal variability, suggesting either surface water or atmospheric processes distributing heat. In places, the surface radiates in such a way that hints at possible cloud cover or even weather patterns. This is not a static world baked evenly by stellar radiation. It is dynamic, complex, and possibly temperate. The implications of that are staggering. One of the most debated questions in exoplanet science is whether tidally locked planets like Proxima B, where one hemisphere permanently faces the star while the other remains in eternal darkness, can support conditions necessary for life. The new imagery provides critical insight here. The twilight zone, or the terminator line between the planet's day and night sides, shows unexpected complexity. There's a smoother gradient of heat distribution than previously imagined, possibly hinting at atmospheric circulation that tempers extremes, moving warmth from the day side to the night side. This revelation challenges previous models that portrayed such worlds as starkly bifurcated between scorched desert and frozen wasteland. Instead, Proxima B might harbor a band of perpetual twilight, a Goldilocks zone within a Goldilocks planet. The planet's surface composition is also beginning to reveal its secrets. Spectral analysis, derived from the Webb's observations, suggests a crust composed of silicate rock, not unlike Earth. There are hints, though as yet unconfirmed, of hydrated minerals, which could suggest a history of water presence. There are no oceans visible in the classic Earth-like sense. Webb's instruments cannot resolve surface liquids directly with current limitations, but there is a telltale spectral signature that might indicate water vapor. This is especially exciting because the question of water is inexorably linked to the question of life. Where there is water, there may be biology. Astronomers are particularly enthralled by the potential presence of a thin atmosphere, which could act as a shield against the high-energy radiation Proxima Centauri is known to emit during solar flares. Proxima B's parent star is notorious for its volatility, frequently unleashing powerful bursts of stellar radiation that can strip atmospheres and sterilize planetary surfaces. But this new data suggests that either the flares are less erosive than feared, or Proxima B possesses some means, possibly magnetic or atmospheric, to resist that barrage. It's a game-changing clue in understanding how potentially habitable worlds might endure in environments once considered hostile by default. Zooming out, the broader implications of this discovery are equally profound. The ability to image a planet just over 4 light-years away with such clarity opens the door to a future in which direct imaging of exoplanets becomes routine rather than exceptional. This wasn't a gas giant observed by blocking out its star, or an approximation inferred from flickers of light. It was a direct focused capture of a rocky exoplanet, revealing its character with startling precision. The scientific community now stands on the precipice of being able to study dozens, even hundreds of Earth-sized worlds around nearby stars, many of which may reside in similar habitable zones. For decades, Proxima B has served as a placeholder in our collective imagination for what an alien Earth might look like. Now that imagination has been anchored by data. The Webb image is not just a technical achievement, it is an existential one. It bridges the conceptual gap between science fiction and science fact. What was once an artist's impression can now be replaced by empirical visuals grounded in physical data. The leap from speculative to observable transforms how humanity approaches its place in the cosmos. Astronomers are already recalibrating their models of Proxima B based on this image. Climate models, once theoretical, are now being cross-checked against observable temperature gradients. Geophysical theories about crust composition and tectonic potential can now incorporate visual and spectral evidence. Even the modeling of Proxima Centauri itself will likely be revised, as the interaction between the star and its planet can now be studied in the context of actual planetary response, not just stellar output. The release of this image has also re-energized public interest in interstellar exploration. While robotic missions to such a distant world remain decades, if not centuries away, the idea feels a little less like fantasy now. Organizations such as Breakthrough Starshot, which aim to send miniature probes to the Alpha Centauri system within a human lifetime, gain renewed relevance and urgency. For them, and for the broader visionaries of space exploration, this image of Proxima B is not just a target, it is a destination. Importantly, the image of Proxima B also highlights the James Webb Space Telescope's capacity to exceed expectations. When the telescope was launched, it carried with it the hopes of astronomers worldwide, promising insight into the earliest galaxies and the atmospheres of distant worlds. With this capture, Webb has proven that its potential reaches even further. By mastering the delicate art of exoplanet imaging so close to a bright parent star, it has set a precedent for what is technologically possible. The feat was akin to spotting a firefly next to a lighthouse from miles away and not just seeing it, but discerning its wings, its movements, its heat. Beyond astronomy, the psychological and philosophical implications of this image ripple outward. Humanity has, for the first time, seen the detailed face of a potentially habitable planet around another star. It is not simply a world that could be like Earth. It is a world that we now know is real, solid, and visible. This reframes the way people think about the universe. The stars above are no longer abstract pinpoints in the night sky. They are suns, and some of them have planets. And some of those planets may one day be reachable or even livable. The emotional response to the image has been striking. Scientists, seasoned veterans of data and analysis, have expressed awe and even reverence. For many, this moment echoes the first images of Earth from space, when the blue marble photo from Apollo 17 redefined global consciousness. Now, Proxima B offers a similar paradigm shift. It is the mirror image of that blue marble. An alien world, yet echoing something familiar. Suspended in the void, calling to something primal within the human spirit. The need to explore, to understand, to find kinship in the cosmos. If you like this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on the new Proxima B image? We want to hear from you. Thank you for watching, and see you next time.